In problem number 12 on sample final part 2, we have a skateboard weighing 39 newtons, represented by a force G, so that's that 39 newtons, lies on a hill inclined 39 degrees, so here's our 39 degrees. And in part A, they want us to find the magnitude of the force Q required to prevent the skateboard from rolling downhill, so that's our Q. And then they want us to find C, that is the force of the skateboard against the hill, so that's C. I won't show today why this angle from G to, I'll call this point here A, from GAC is equal to the 39 degrees. I'll share that at the end of the video if you want to watch why. But we're going to operate with this angle here is 39 degrees. So I'm going to construct a new triangle. I'm going to have the one that's with the vertical. That's my G. And that's the 39 newtons. And then I'm going to have another angle. And that's C. And C is going to be perpendicular to that incline. So this is the incline, and I'm trying to make sure I draw these two the same. They don't quite look the same. All right, so let me go ahead and label C. And this guy here is Q. And let me erase this guy here. So I'm going to draw this new triangle. That has that 39 newtons. It has C. And then I'm going to draw a line parallel to Q. I should say a line segment. So that's going to be my Q. All right. And I know this angle here is 39 degrees. So now really all you have is a right triangle. And if you want to get a different visual, I've really just reproduced the triangle like so. So I drew a line parallel to Q between G and C. There we go, we got it. Well, it turns out this is just a right triangle trig now. So you just have to make sure you label the sides appropriately. So we want to find Q. So Q is our unknown here. My Q looks a little scary. Let's make that look a little bit better. So here is Q. Come on, Q. There we go. So that's my Q. So our first problem, they want us to find Q. So I noticed that Q is opposite the 39 degrees. And I noticed that the 39 newtons, which was my G, is opposite the right angle, so that's my hypotenuse. So I have the opposite that's unknown, and I have the hypotenuse. So what trig function uses opposite and hypotenuse? Well, that's going to be sine. So we have that the sine of 39 degrees is going to equal Q over 39. It's interesting that both have the same value. So if I multiply both sides by 39, so if I multiply both sides by 39, then I'll have 39 sine 39 is Q. So I'll go out to the Alex calculator and get that value. So we got 24.543, and they want us to round to the nearest 100. So that'll leave us with 24.54. And since that's a force, that's going to be my newtons. All right, so my first answer will be 24.54 newtons. All right, the next question, we're asked to find C. So C is adjacent to the angle of 39 and the hypotenuse of 39. So the cosine uses adjacent and hypotenuse. So I'm going to take the cosine of 39 degrees is equal to C over 39. Multiplying both sides by 39, I get 39 cosine 39 is equal to C. Evaluating this on the Alex calculator, we get 30.6 30.308 newtons, which is going to round to 30.31 to the nearest tenth. For this problem, there are going to be times where they will give you C and ask you to find Q and G. So you have to be careful. Depending on what they give, that will change the nature of the trig function you use. But the angle of inclination will always be this angle here. So let's go out and talk about why is it that 39 degrees is the same angle here of 39 degrees. So I'm going to make this a little bigger so we can see. So I'm going to label these angles. I'm going to call this angle here alpha. And I'm going to draw my right angle here. For my gravitational vector is going to be perpendicular to this horizontal line. All right. Then, which is representing the regular ground, not on the hill. All right. Now, it turns out because this is a right angle, then we know that 39 and alpha are going to add up to 90 degrees because all of them have to add to 180. So we're going to take 39 degrees plus alpha is equal to 90 degrees. So when we subtract 90 degrees, 39 from 90 degrees, we're going to have the value for alpha. So 90 minus 40 is 50, so it'll be 51 degrees. All right, so we get 51 degrees for alpha. And then it turns out that the angle, and I'll draw it in blue, for the angle of inclination is perpendicular to C. So I'm going to call this angle beta, which is the one that I make some statements about earlier. It turns out that alpha plus beta is also going to equal 90 degrees. But we found out that alpha was 51 degrees. So 51 degrees plus beta is equal to 90 degrees. So if you subtract 51 from both sides, you get beta is 90. Beta it's beta. Beta is equal to 90 minus 51 degrees, which is 39 degrees. So that's why beta will always equal the angle of inclination. So beta equals 39 degrees. All right, so I hope this video, this one is on problem number, which one was it? Let me shrink it back down. Problem number 12. Number 12 on the sample final part 2.